Okay, so the next lecture here is the present value of a single amount. So, we had just done future value of a single amount. Now we're going to do present value of a single amount. Let's kind of walk through it. We're going to kind of use the same process. I feel like having a framework for learning is important. So we're just going to kind of work through the same framework every single time. And so, in this case, obviously, we're working from the future. We're starting from the future and working our way back, right? So we want to say, okay, I have some amount off into the future. How much would that be worth today? And it's going to depend on a lot of factors like how long, the interest rate, all kinds of things. But that's the whole idea of this type of calculation. So whenever there's some amount off into the future, we're trying to figure out how much is that worth today. And actually, in accounting, most of the application for time value of money is a present value application. So this is one that you're going to need to use a lot. So just be prepared for that. All right. So, company agrees to pay the bank $13,310 at the end of a 3-year note. They apply a $10,000 discount rate to the note. What is the present value? So the timeline really looks the same, but you can see the direction is going backwards instead of forward. So really what we're doing is we're saying, okay, so I've got $13,310 that they're going to pay in the future. If I have a 10% discount rate and I don't have to pay it for 3 years, well, how much is that really worth today? So if I were, bank, how much should the bank be willing to lend me if these are what we agree are fair terms? And so what we do is, again, we take that 13,310, we discount it back for 1 year, so that we discount it back 10% 1 year. So now this is the new basis. We discount it back another year, so now that's a new basis. And then we discount it back 1 more year, and that gets us to our present value. So really they're mirrors, right? So future value calculations take amount today, move it forward in time. A present value calculation takes a future amount and moves it backward in time. And much like we had illustrated with the future value calculation, if we want to compound more frequently than just annually, it would change things, because now instead of 10% annually, it would be 5% semi-annually. So we'd kind of go here and then we'd stop and we'd have a new basis. And then we'd go again and have a new basis and then kind of move our way through time like that. So it'd sort of be increasing the number of times that we're discounting. And what happens is it starts to reduce that present value. So the more often, the more frequently we discount, that present value is going to get driven down. Again, because now we're taking a new basis and we're working down much more quickly. All right, so kind of taking a look at that. Hopefully, again, just the notion of how that looks makes sense. And so we'll kind of go from there. All right, so the equation approach. So we're going to talk about an equation first. Again, you need to be able to apply this equation. This is an equation that you need to know and be able to apply. Again, a little more algebra here. So in this case, we have the 13,310. And the way that you discount using an interest rate is really you divide by the 1 plus whatever that interest rate is. And that's really how you discount backwards. And we really do that 3 times in this problem. And so what you can see really is what you have is that numerator, the 13,310, that's the basis. We're discounting it 3 times by 10%. And that's where we get sort of this, so you can sort of see the equation forming. You have the interest rate and you have the number of periods, and that gets us our 10,000. So, we kind of take it as a general form. We know the present value is going to now equal the future value divided by 1 plus I over n. And the reason why I rewrite it this way is because we're really isolating what we call the present value factor. And so this second term, when we start using the tables, will be the basis for our present value factor. Now, as far as a test in applying the equation, if you want to use this equation, that's fine, or you can use this equation. Either one would be completely fine with me. But again, when we're using that equation, now I know if I have a future value, I have an interest rate, and I have an n, I can discount it back and get a present value. But again, now this second term becomes really important when we think about our tables, because that is going to be our present value factor. And so looking at that, again, that second piece is what we understand from our factor table. So applying that factor to our problem, we have a 10% interest rate and we're discounting it for 3 periods. And so when we calculate that through, we get a factor of 0.7513. And really what that means is that 0.7513, it's the factor that corresponds to any problem where you have a future value and you're trying to calculate a present value where there's a 10% discount rate for 3 periods. All right, so that is what we would use every single time. And so again, in our ongoing example, we have this basis of 13,310, and we're trying to figure out, how do I use the table in order to solve for the present value given a 10% interest rate and 3 periods? And so this is a second table. It is not the same table as the one you saw. I mean, it's the same interest rates and it's the same number of periods, but all the factors are different because these are present value factors instead of future value factors. And you hopefully saw that the future value factor was, sort of 1 plus I to the nth, whereas the present value factor is 1 over that term. And so it is a little bit different. And so in this case, of course, we're looking for the intersection of 10% and 3 periods. And that, of course, is where we find that 0.7513 factor. And so then we apply it to our basis, which again, we're trying to figure out what is the present value of this number. So we apply the basis again through multiplication. We apply every factor through multiplication. 13,310 times our factor gives us $10,000. All right, so this next one, I want you to try to do on your own. So we have, we want to know, what is the present value of $15,000 that will be paid in 7 years if the company uses 8% interest compounded annually? So we're trying to figure out, okay, what would the present value of that be? And so again, 7 years, 8%. And so looking at our table, again, sort of 7 years, 8%. In your mind, kind of focus in on the factor that we'd use. If you need to pause it to solve it, please do so. Hit pause and then we'll pick it up. So again, hopefully you pause there. And so looking at this, again, we know it's 8% is our I/Y, 7 years is our N, and the intersection of that is 0.5835. And so then we apply that to our basis, which is 15,000. And we get a present value of $8,752.50. So that is the present value of $15,000 that's going to be paid in 7 years if they use an 8% interest rate. All right, hopefully you get an idea of how to use that. Now we're going to use our time value of money calculator. We're going to start with, sort of that ongoing example, $13,310 in 3 years. And we're going to apply a 10% discount rate. Again, in this case, instead of solving for FV, we're solving for PV. So we're solving for a different number, but we still need to fill in the other 4. And so I'm always intentional. I always put something in for every single one, even if something, in this case, like payment, even though payment, there really isn't one, I'm going to specifically tell my calculator that the payment is 0. And so I make sure I put everything in. And so again, hopefully this is something that you can do. If you want to pause, to do it on your own, that's fine. But I'm going to kind of keep rolling here. And so of course, our N is 3. So again, 3, then N, so number, then button. Our I/Y is 10. We know that there is no payment. And then the FV again is 13,310. Honestly, I probably should have put a negative here. Would probably have been the best way to do that. But positive or negative, it doesn't matter. So 13,310, and then again, compute present value. So hit the CPT button, then present value, and you should get $10,000. Again, hopefully that's something that you're getting used to using your calculator. There's plenty of tutorials out there and using it. I'm going to have different examples here, of course. But if you're not familiar with the TVM calculator, you should spend some time getting used to it, because I will say of the tools, of the TVM tools, the calculator is the one that I use the most. And from talking to colleagues, they use Excel a lot or their calculator. Pretty much no one uses a table and no one uses equations. So you either use Excel or you use your calculator. All right, so let's do the other one. So again, try this one on your own. If you need to pause, please do so. And then we'll pick it up. So again, hopefully you paused it. Again, the inputs, 7 is our year, 8% is our discount rate, Our future value is 15,000, and we calculate that. We get a present value of $8,752.50. So hopefully that makes sense. But again, that's the present value of a lump sum. We've done the future value of a lump sum. Now we've done the present value of a lump sum, and I think we're about at 15 minutes. And so we're gonna stop this one here, and then we will pick up solving for some other things here in just a minute.